Hi everyone, this is Stephen Pu, founder of the Terraxo project, and welcome to our Blockchain 101 series. And today we'll answer a very basic question. What exactly is blockchain? Okay, so without really going into any technical details, we think blockchain really has three core functionalities, right? So the first thing that a blockchain actually allows someone to do, and that someone could be a person, a machine, it could be an organization, is some sort of an entity, right? It allows that entity to commit statements, right? So the statements can be anything, right? I have a dollar, Bob owes me a dollar, the sun is rising in the east, or I'm a machine and I'm broken, right? So it can be any sort of statements. What's unique about these statements is that they all come from a specific source, and that source can be traced with cryptographic signatures. So you know exactly where it's actually coming from, right? So you can't falsify someone else's signature, you cannot falsify someone else's identity. So you always know where these committed statements are coming from, right? So blockchain allows an entity to commit statements. A blockchain also, what it also does is that after the statements have been committed, the network has algorithms that allows the network as a whole to really agree on what is true, right? So has a way to agree on reality. Now, one thing to be very specific here is that what they agree upon might not be the truth, but it is a version of truth that the network was able to agree upon. It depends on the types of algorithms. Some networks have these implicit algorithms, such as Bitcoin. For example, whatever is stored on the longest chain is always true, right? Some networks have very explicit algorithms in which the nodes actually take a vote, right? They vote on what they believe to be true, and the outcome decides what's true. So a blockchain network, a blockchain system always has a mechanism for the network to agree on reality. Okay. And the third thing is on a blockchain network, all the nodes they replicate records, right? So everyone has a copy of the same thing. So you have all these committed statements, right? And what the network has agreed upon, all of that, everyone has the same copy, right? So they're just exact same copies on every single node. So that's pretty much it. These are the three core things that a blockchain does. Pretty simple. Now, you may hear in the news or project teams talk about this. A lot of interesting properties that are involved with blockchain systems. Well, they can all really be traced back to these three properties, right? So, first thing I think everyone hears about a lot about is immutable, right? So, what is on the blockchain can never really be changed, right? That's the most common thing everyone hears about. Well, what does that mean, right? How does that happen? Well, the first thing that you think about when you think about immutability is because everyone has a copy, right? So if only one person has a copy, then you can just bribe that person, or maybe that's a system. You can hack the system. You can do something to it, and you can change what's true. You can change the records, right? That's a single point of failure. But if there are hundreds or maybe even thousands of nodes out there that everyone has a copy of the same thing, and you want to change records and you want to change reality, it gets much harder, right? So depending on what the system by which the network agrees on reality, right, this also plays into it, you have to compromise or bribe a lot of different nodes for you to be able to change the data, right? So it's not impossible to change what's actually stored on the blockchain. It's just really hard to do if you actually design the blockchain right. Okay, so that's what immutable means. You also hear a lot about this idea about no double spending, right? What does that mean? Well, double spending is this concept that I can, if I have a dollar, I can send Alice a dollar, and then right afterwards I can send Bob the same dollar, and the system wouldn't be able to tell, and they'll just say, well, Steven sent out $2, but in reality I only have $1 to spend. So that's what a double spend means. Well, so how does the blockchain system prevent double spending? Well, everything on the blockchain is ordered, right? And that really comes from this agree on reality part of things, right? So all these committed statements are sorted in a specific order. So once that order has been agreed upon, everyone has a copy of it, right? So What that ordering means is that if I spend $1 and give it to Alice, and then I spend another dollar and give it to Bob, those two transactions have to be in a specific order. And it doesn't really matter which order it comes in, the one that came in second will be invalid, right? Because I spent $1, sent it to Alice, now I have $0, and I try to spend another dollar, send it to Bob, the system will say, well, sorry, error, that transaction failed because you have no money to send to anyone else. So because the system is actually able to agree on a version of reality, and ordering is one of the critical elements of what reality means, there's really no double spend, right? You can't spend the same money over and over again. The third thing that you might hear about is this idea of accountability, right? So you can actually make sure that entities are accountable for what they're saying, right? And this really comes from this idea of committing the statement and the fact that, everyone has a copy. So you said something, right? You said, I have $2 or something like that, or I owe Alice $2, right? And that has been committed. It definitely came from me. It came from no one else. It's not possible that it came from anyone else. It only came from me because there's signature on it. So I'm locked in, right? Once I'm locked in, everyone has a copy of it, right? So I can't really change it. So now everyone knows about it, right? Everyone knows about the fact that I owe Alice $2. So now I'm accountable, right? That message, that information is on the blockchain forever, and it can be traced back to me. So I'm perfectly accountable for the things that I say. So these are, some basic functionalities and some of the very interesting properties that these functionalities enable on a blockchain. Hopefully that's helpful. Thank you.